Okay, so this is your worksheet 4. You can download this worksheet and rename it with your ID number. And also in the inside the lab sheet also you have to rename it, right? There's a cage to fill the ID number, so you have to rename it even in the worksheet. And when you upload it, make sure to upload only the PDF documents, okay? And here are the references. You are given with 3 different references. You can download these references, right? Because you can find answers for this lab 4 from these references. And I want you to read them because when you are doing lab class test, you need these references, right? So it's better to read it and get some knowledge regarding this structured cabling before you participate in the lab class test. Because during the class test, you don't have time to search for the answers. So therefore, it's better to do it before that. Okay. So we are going to complete this lab session today, and I'll give you some introduction about the lab. I hope those who have downloaded the lab sheet is already referring to the lab work that you have to do today, right? So if you have read the lab sheet, you can find answers from the discussion as well. And time to time, you can share your knowledge and also you can ask questions via the chat, right? So then we'll see what's today's plan. We are going to learn about structured cabling and some testing methods used in structured cabling, right? Now, when we work in the industry, especially with related to computer networks, you may have a doubt, what are the things that we have to do as a network administrator or as a network engineer? So when you work in the industry, you have to maintain your computer network because most of the time we can see in most of these organizations purchase this facility as from a third party organization, right? Now, when we consider even in our SLIT Academy, the network is actually prepared not by a third party organization because it was not prepared by as a own product, but we are maintaining the network, right? But if there's a major problem, if there's a troubleshoot, we need to contact the third party to get the services, right? So that's how we usually handle a network because network is something that you establish at the beginning and then you have to maintain, right? You need to do troubleshooting, continuous troubleshooting and continuous maintenance. That's what we have to do. It's not like a software development, right? It's not like a system administration, okay? So that's why we find very rare opportunities in network administration and engineering because we have a few organizations who do networking for other companies. And once they complete it, they provide only the service level facility to do troubleshooting and to maintain or expanding their network, right? So what do we do in here as structured cabling? That's what we need to know. And we are going to see some structures like images to identify what's actually mean as a structured cabling. Structured cabling systems refer to telecommunications wiring built in a standardized, approved manner, starting at the demarcation point, working through the various equipment rooms, and continuing to the work area. The issue of scalability also is addressed. Now, at the beginning, I know that you don't have any idea about what is this structured cabling system. And as you can see, it explains with a few new terms like demarcation point, equipment room, working area, scalability, right? So actually what we get from structured cabling is the scalability. That is the main facility that we need to address in here. Now, when you want to expand your network further, let's say if we are planning to expand at least one floor, right? If you want to expand your working area at least for another floor to have another department or to have more employees, then we need to plan for this structured cabling, whether it is capable to expand it into another floor, right? So likewise, we need to think about the scalability. Scalability means if is it possible to expand it further. And here we have some new points like demarcation point, right? And equipment rooms. So time to time, we'll see what are they. What we get from structured cabling. It provides you a systematic approach for cabling. Now we discuss about cable, transmission media, guided media as copper cables, coaxial cables, twisted pair cables, and fiber optic cables. Now, how do we consider the layout of these cables? Layout, again, we discuss as a topology, right? I think you can remember physical topologies, right? We discuss about several physical topologies. So what do we get from these topologies and cabling structures? We can build a network. The network should be a systematic network. Otherwise, it is very difficult to troubleshoot and maintain. Now, when we discuss about topologies, we identify each and every topology advantages and disadvantages. But when it comes to topologies, we discuss with very few amount of devices, right? For an example, if we take ring topologies, we discuss it with few devices, like 5 or 6 devices. Even with mesh topology, it has the same scenario. We discuss it with few number of devices. But in actual environment, in an organization, you can find so many devices, so many computers and printers, scanners, any other devices, like not only these printers and scanners, even VoIP telephones, digital phones are also comes under this network, right? So therefore, we need to maintain a proper systematic network in any organization. That's where we introduce this type of structured cabling. It is a complete system of cabling and associated hardware which provides a comprehensive telecommunication infrastructure. So in any organization, we need to purchase the internet connection from a telecommunication service provider. So from that point onward, how do we expand it further? Now, at your home also, you can experience a small network. You have purchased internet connection from a telecommunications service provider, and all of the devices are connected to your Wi-Fi router, right? Either you are connected as a wireless connection, or even if you want, you can connect with a cable, because Wi-Fi router also comes with ports where you can connect in via cables. So either you can have a physical connection or a wireless communication method. Anyway, we can connect several devices, right? Not only your laptop, even you can connect a desktop PC, your mobile phones, right? Smart tablets, right? Likewise, you can connect many other devices into your home Wi-Fi router. In organization network, we have routers, switches, which are connecting all the devices together. But we should have a proper plan. That's what we are going to discuss in this lesson, right? In previous lessons, you have identified what are the cables, transmission media, and also we did a lecture for topologies, and we discussed about what are the networking devices that we can accommodate in a computer network. But though we have cables, devices, and if you know the topology, if you don't know how to build this infrastructure properly without a mess, it would be uh, like helpless, right? Your network administrators, engineers will be helpless because when you found a problem in the network, they can't do anything, right? So you have to properly build this infrastructure by considering all the devices and every connection in the organization. This infrastructure serves a wide range of users, such as to provide telephone service or transmit data through a computer network. Now in here, we have so many users, right? In organization, usually we have around 50 to 100 users, right? In a usual medium scale business, right? If you take our Slit Academy network also, we have around 100, 150 computers in labs, right? Because we have 4 labs. So in all 4 labs, there are around 150 PCs. So all of these PCs are connected together. But how do we maintain it now? Though they are connected with switches and other devices, cables, how do we maintain it properly without a mess? That's where we need structured cabling, right? It should not be device dependent. Now, structured cabling is also introduced as an independent infrastructure because when we discuss about devices also, I told you every device is having common functionalities. Now, if you take a router works in the network layer. And when we discuss about ISO/SI 7 layers networking models, they also have highlighted that we can increase the competition between these users by using these different types of devices, like different types of devices purchased from different vendors. How do we buy these devices from different vendors? It's because they are using the same standardization. So if you have networking devices like routers, if there's only one vendor to purchase all of these things, it's because of the functionalities that they provide, it would be a problem, right? So that's why in ISO/SI 7 layers or layered architecture also, they have provided layer design and allocated each and every networking device into separate layers. Now, for an example, router works in network layer. Switches we have 2 types, layer 2 and layer 3. Layer 2 switches and bridges are working in the data link layer. So when it comes to data link layer, we are completing certain functionalities in the data link layer. For network layer, it works with logical IP addressing like IP version 4 or IP version 6 address method, and it completes certain functionalities. So likewise, we can identify specific activities with related to each and every layer. So according to that, in order to fulfill them, vendors or manufacturers also manufacturing different devices to match with the functionalities, right? So then you don't need to purchase all the devices from one manufacturer. We can go for different manufacturers. So using structured cabling method, it has given you a infrastructure where you can purchase devices from any vendor. And also you can purchase cables and other equipments from any other vendors because they have a proper standardization. Now, if you examine the documentations which I have given you as references, you also can see they're explaining you with some standardization. So they've used some specifications and proper guidelines when they implement this structured cabling. Now, what we can see as a structured cabling system. Now, in a small network where you have few number of computers, you can see this type of environment where you have a patch panel cabinet connecting all the devices together via horizontal and vertical cabling together. Right here, we can see there are two users in two different floors in the same building. And so there's a wall outlet in here, right? There's a wall outlet. Now, at your home, you can't find this type of wall outlet, but if you have ever been to office or any, like at least if you have been to this academy office, I think you can see this type of wall outlets which are connecting your PCs together, right? So PC is connected with a patch cable. So patch cable means actually we can use either copper cables or twisted pair cables, or else we can go for fiber optic cables, right? So that's your preference. And connect with this wall outlet and the PC. And then we have vertical cablings and horizontal cablings, basically the backbone cabling structure to connect all of these devices together. And all of these connections comes to this server room patch panel, right? So inside the server room, we have patch panels and all the racks which we can hold switches, routers into the equipment racks, cabinets, right? So what is this? This is the demarcation point, okay? The structured cabling system begins at the point where the service provider terminates, which is known as demarcation point or demarc. Also, we use this term as network interface device, right? NID, right? Network interface device or demarc. The short name is demarc, right? I told you we need to purchase this connection, internet connection from a telephone or telecommunication service provider. Now, for an example, if you take SLT as a service provider, SLT is an internet service provider. But when it comes to our telecommunication services available in the country, it plays that internet service provider role as well as the usual telecommunication service provider role for the country subscribers. So service provider is giving you a connection point. Even at your home, you can find this demarcation point because there's a small box where you have all the connections come from the outside connection to your home. So you can check from where you get the connection to your home. If you have purchased a SLT connection, this is very easy to find it with because from SLT connection, even with fiber or either copper cable connection, they are providing you a demarcation point. So this demarcation point is the end point of the service provider because that like from this point onwards, if you consider the outside network, it's a huge network maintained by service provider. But from the demarcation point onwards, the home side, it's your own private network, right? So this connection which comes from the telecommunications service provider terminate at this demarcation point, right? Even at your home, you can find this demarcation point, right? So whenever there's a problem in the network connection, usually they will come and check you demarcation point, right? So that's where they identify whether there's a problem in this network, or is it from the cables, or is it from this point, right? Some connection problems in these fuses, right? Likewise, it will identify any problems first from the demarcation point, okay? So every communication network, we need to have a demarcation point like this. Okay. So I think you can answer the very first two questions in the lab sheet. So in the lab sheet, you have to fill these cages. What do you understand by structured cabling? I think you can answer for the first question, right? What do you understand by structured cabling? So structured cabling means it's a system which it's a systematic approach for cabling with a proper telecommunication wiring standards. And it's starting at the demarcation point and connecting several equipment rooms and continuity to the working area where we can build a comprehensive telecommunication infrastructure. So you can find what do you mean by the structured cabling from here. Okay, so even if you refer into our reference, you can find what you mean by, what you understand by structured cabling, then answer for that question. Even from this slide, you can find what is the answer for that question, right? Okay, so now we'll see why do we need it. Now we saw that from where we can start this structured cabling system. It is starting from the demarcation point, and that works as the ending point of the service provider's network, right? So from there onward, we have the subscriber. So subscriber can be like a company, right? Because when it comes to the subscribers, especially with related to organization level networks, we have one subscriber, right? Your organization employs the subscriber. Okay. So inside the organization, we can find several users, but they don't come as subscribers. Subscriber means your whatever the user who is taking the service from the service providers. So why do we need it? This is why we need it, right? Why do we need a structured cabling environment? It's because this. So we need to arrange this network from here to here. So that's the duty of the administrators and network engineers. So at the preparation of the network also, if you can follow up these rules and implement your network, it won't be a mess like this, because you can easily maintain your network. As you can see, even in this network, everything is there, right? I'm sorry. Okay, now it's okay. I'm sorry. Now in here, you can see why we need it, this picture, right? Why do we need it? We need to change this environment from this environment into a properly organized environment like this. Now, this is the duty of administrators and network engineers. They need to prepare this network like this from the beginning, right? From the beginning, if you do it like this, it won't be a mess like this, right? Which is on the left-hand side. Now, as you can see, this same diagram, same location, once they like before they arrange it, and once they arrange it, this is how it looks like. Okay, so do not think that arranging the cables is actually what is meant as a structured cabling. Behind the scene, we have so many other work to do, right? Because when you implement a network at the very beginning, you need to plan for the network design, right? We can't straight away start the network design as we wish, right? Let's say if you have 20 users in your organization, and all of them are having 20 computers. So then you have to decide what are the networking devices we need. How do we connect them with each other? Now, when you consider the infrastructure of the building, floor plan, how many floors you have, right? Like, let's say if it is just a single floor, then again, we need to consider what are the cabins available in the whatever the flow, right? Let's say if you have only one particular flow, right, for all 20 users, everyone is working in separate department, right? No one will work in the same department, right? We are working in different departments, and also to separate each and every departments, we have cabins and partitions. So we need to identify that infrastructure as well, the building infrastructure to do this implementation. It's not only for converting this messy cabling infrastructure to a properly systematic design, right? Not only for this, actually from the beginning, when you're planning the design, network design, from there onwards, you have to do structured cabling, right? So this is just a diagram to show you this is what we are going to do, right? Actually, with structured cabling, this is the plan that we can see, but at the beginning, from the beginning of the implementation of the network, you have to follow these guidelines. Okay, so why do we need it further? We need to maintain the consistency of the design and installation. Now, as I told you, here you can see a flow plan, right? So this is a flow plan. Now, in this flow plan of this particular office, you can see in this corner, there's the server room. So all of the connections comes from different departments, and these partitions should come and ended up in that server room, right? So every organization where they have IT infrastructure, they usually maintain something called server room. In our SLIT Academy also, we have a server room, right? So server room is that's the place where we have servers and all the networking equipment, and every connection comes to this room, right? We are giving a different name for this server room finally, because we have different names. There we will replace this server room with a different name. But until that, we get all the connections from different departments and different sections to this server room. Okay. So when you consider this flow plan, how many departments we can see? We have programmers department, manager room, sales department, accounting department, and technical support department, right? So all of these departments are equipped with computers. As you can see here, we have 3 computers, right? And all 3 are connected to these wall outlets, right? Here we have some wall outlets, connection outlets, right? Here. And here also we have 3 connections. Now with 3 connections, you can see this connection comes over here and connected to this wall outlet, right? Likewise, there are wall outlets in here, but we have only 3 computers. But when you have, when you want to expand it further, we have some wall outlets kept as blank, right? Free wall outlets. So you can connect more devices in the sales department. So like this, we may have several connections together in each and every room. So all of these connections at the end comes to this server room. Okay. So we need to maintain the consistency of the design and the installation. So before you design the structured cabling infrastructure, you need to take the plan of the building. Now, let's say this is the first time that they are going to build a new IT infrastructure for the organization. Let's say they are currently using manual process and they want to move on into a IT infrastructure and computerize everything, right? So then if they plan to implement a network, you need to take the flow plan. What are the departments and how do they separate with each other, right? How many computers we are going to provide in each and every department. Likewise, you need to get their requirements. It's like when you are implementing new software, you have to follow up certain processes, right? You need to complete the SDLC cycle. Similarly, in network implementation also, you have to collect the requirements from the users, right? There's a question regarding the demarcation point. Now, actually, in this picture, you can't see where the demarcation point is. Demarcation point comes as the entrance facility. But in this picture, since we have only one floor, we are considering only one floor. So we can assume that the demarcation point is also comes to this server room, right? But in this picture, we don't have, well, it's not actually well-equipped one because we are just providing you a flow plan, right? Now, what else we have? This conformance to physical and transmission line requirements. So we can identify what are the physical connections that we need, how many users, how many transmission lines are required, right? How many transmission lines means when you purchase the cables also, you can't purchase cables as you wish, right? You have to decide what is the transmission media we are going to install in the environment. It's not only based on the values, right? Not always based on the prices. You have to determine it with the requirements. So if it is a very highly computerized zone where you expect high data transmission rates, so then we can choose even fiber optic connections within the building, right? That's your requirement. You have to list down these requirements before you install it. So that's why we need a structured cabling method. It's time saving. Obviously, it is time saving. If you had a problem in the network, you can easily identify what went wrong and what are the things that you need to fix with. Reduce potential downtime. So since you can easily manage the network and easily identify the problems in the network, you can reduce the downtime. So likewise, we have several other users, manageability, support for multi-build equipments. Manageability means you can see how many connections are there, and if you want to expand it further, it's easy to expand it, right? And support for multi-band equipments. Now, this network is not depends according to the manufacturer's devices, right? You can purchase any device from any manufacturer, no restrictions, right? No need to go for very expensive devices. You can even purchase cheap devices if you can get the service. Sometimes we can rent out these devices. Now, for an example, we have experience for servers. We can rent out these servers from other service providers who are providing it, right? So then there's a third party who involves from there onwards. So then you have to sign off some service level agreements with them to maintain your servers. So likewise, it's simplifying moves, add-ins, and changes. As you can see, I told you that we can expand this network further by adding more computers, by considering number of outlets we have, right, wall outlets. And we can easily add new devices, as well as if there's a problem in one of these devices, we can easily replace them. Simplify the troubleshooting. support for future applications, and uniform documentation. Now, if there's a problem in the network, you can easily identify them. And this supports for future applications. That means if you want to increase the technology used in here, we need to replace, like, let's say you need to purchase new computers, but you don't need to replace their cable network, right? So likewise, if you want to expand it further, you can add more devices by adding this number of wall outlets. Uniform documentation. Now, what is this uniform documentation? We think that for networking, we don't need to do any documentation, but that's not the truth. We need to document every action that we do, right? So as the network engineers, they need to document all the equipments that they have used in this environment. Because if there's a new person comes in to work with this environment, they should know what are the devices and what are their capabilities, right? So if you purchase any servers, if you have purchased any cables, computers, networking devices like routers, switches, everything should be documented. And once you connect with each other, we do some configurations in, especially in networking devices. Now, for an example, if you take one of your computer, what are the softwares, application softwares installed with? What is operating system you have used? Likewise, you have a list of softwares and operating systems you have used in your computer. But since it is your own computer, you don't need to worry about it. But if it is a organizational level computer, always you have to determine what is operating system, how many application softwares are installed in here, and what are they. Likewise, you have a specified list of softwares, right? But when you come to network, similarly, you have to determine how many devices are there, how many wall outlets, network wall outlets are there, how many connections comes to first patch panel, how many devices comes to second patch panel, how many switches. You need to document everything. And also their specification, like even if you take servers, you know that different servers provide you different capabilities, right? If you compare with your own PCs, you know that every PC is using different types of processors, right? They use different types of motherboards. So likewise, we have some hardware specified so some information like specifications. Similarly, you have to document everything, even in structured cable, right? What is a server and what are the operating systems installed with any RAM or CPU facilities used in the server, like this, everything should be documented, right? So that is what we call as uniform documentation. Even you have to draw the flow plan and show what are the connections and where do you have these wall outlets, likewise. Okay. Okay. For question, there's a question. This conformance to physical and transmission line requirements, that's not clear. That means you have to identify what are the devices and transmission media requirements related to your flow plan. Conformance means you need to confirm what are the physical and transmission lines. Now, physical and transmission lines means now when you have a wireless connection, you don't have this much of complex architecture. Let's say if you have 5 computers and each and every one is connected via a wireless router. So then we don't have this complex architecture because everyone is connected via wireless connection. We don't have cables, but whenever you have cable local area network, physical local area network, then we need to consider how many cables, how many networking devices. Now, when you are connecting them also, sometimes like even with topologies, you saw how do we connect with each other, right? Sometimes we are using star topology. So then we have to determine what is a central device. It can be either hub or sometimes you can use switches. But if you have more and more devices, hub is not a efficient method to do data transmission. So then you have to choose switches. So like this, you need to confirm what are the devices, because time to time you can't change these things. In a structured cabling, you can't change it time to time. Now, especially when it comes to software, we have seen like in software development, we can update it frequently. We can provide new patches and update it time to time, right? But with devices, especially with this type of environment, network environment, we can't update it as we wish time to time, right? So that's why we need to stick into one of these standard or specific methodology from the beginning, right? Okay, so while you're like listening to me, you can write answers to this lab sheet. So time to time, I'll give you time to write answers. I think in the second question, it is asking you to write answers. Why do you need structured cabling? So I think now you have answers for why do you need structured cabling? So you can write answers, right? So I'll give you some time to write it. So in question number 2, you have to write why do you need structured cabling? So we discuss about what are the reasons, right? Why do we need structured cabling? There is a huge list, right? And for question number 3, state what are the rules help to ensure that the structured cabling design projects are both effective and efficient. You can find answers for this from the reference, lab reference number 1, right? So in lab reference number 1, there's a section called Rules of Structured Cabling for LAN. You can read it and find 3 reasons what are the rules, right? So here we have look for complete connectivity solution, plan for future growth, maintain freedom of choice in vendors. Likewise, we have 3 rules, and read it and write it in your own terms, right? Don't write, just copy and paste it, right? If you copy and paste it, I'm not going to give you any marks, right? You can use this term, look for a complete connectivity solution. You can use that term, but read this section and explain it what it means as this, right? Plan for future growth. Read this and write it in your own words using your own examples. Now, for an example in here, it says the number of circuits installed should meet these future requirements as well. Category 5E, Category 6, and fiber optic solutions should be considered feasible to ensure that the future needs will be met. So then you can write an example on your own, right? Think about an example of future, like plan for future growth. Think about your own example and explain it, right? Even for the other 2 points, you have to explain it with your own examples. Read it and get some idea. So then you can write it in your own terms. So I'll give you some time to do it, right? Okay. So in the next question, question number 4, it is asking you to write what are the subsystems associated with a structured cabling system and briefly explain them. So you can find what are the 7 subsystems in here. In this reference, here you have the subsystems with the diagram. Now, usually I'm asking to draw this diagram in a class activity and identify what are the parts or the components in this type of subsystem. So you can see what are the 7 subsystems listed in here. right? This is the diagram, okay? So subsystems of the structured cabling. So there are 7 subsystems. Now in this facility, you can see they get satellite communication method. So that's how they are connected with the telecommunication service providers. So they have entrance in here, as well as they have another entrance facility at this point as an alternate entrance facility. Okay. So this entrance facility is also comes from the service provider. So it's a physical connection, right? So this is the physical connection, comes from the service provider. Okay. So there are 7 subsystems listed in here. You can see what are the 7 subsystems. The demarcation point or demarc with the entrance facility in the equipment room. And then we have telecommunications room, backbone cabling. So backbone cabling also known as vertical cabling. And then we have distribution cabling, also known as horizontal cabling, and work area, equipment room, and finally the administration. So those are the 7 subsystems in a structured cabling environment. So now we'll see what are the other points which related to these systems. Now this is where we stopped, and then we discuss about rules of structured cabling as the third question. And when you implement a network in your organization, in the company, what is the procedure to follow up? What are the steps to implement this network? So then we are going to consider what are the steps, right? So I'll come to question number 4 then. Choosing the appropriate LAN devices. So inter-network devices and intra-network devices, that you have to clearly identify, because inter-network devices means devices which can route data packets through the wide area network, right? So who are the devices who can route data packets throughout the network in a wide area network? That is routers, right? So routers are the primary devices used to interconnect networks that use different technologies. They can have both LAN and wide area network interfaces. So routers are the devices who can work with other networks, right? They can interconnect any local area networks together. Local area network means that's your scope. Now, if you are working in an organization, local area network is your own network, right? It's maintained by your organization itself, and you have a separate team to maintain, to look after the devices. Everything will be take care by the people who are working in the organization, or especially the IT department. But when you work in the communicate with other organization networks, you have to interconnect with the internet. So how do we interconnected with internet or either other wide area network technologies? That's where we need routers. So if you plan to communicate with other networks, if you want internet facility, you need to purchase routers or layer 3 switches. Layer 3 switches are also capable to work with outside network, because layer 3 switches also can read IP addresses and route data packets to the destination. Okay. And also you have to determine what are the intra-network devices. Inter-network means outside network, public network or internet. Intra-network devices. Intranet means your internal network, local area network, right? In general, switches are chosen for connecting devices to a LAN. So how do we connect each other together? We can't connect them with cables, right? We have to use cables, but if you try to plan to implement a mesh topology, it won't be easy, right? Because you have many number of devices in the network. So you're interconnected with them either by using switches or using hubs. And also when you purchase a switch, what are the things that you have to think? The number and types of ports available. When you purchase a switch, always you have to check how many ports, how many devices can be connected to this switch. So switches comes with different number of ports. It can have 16 ports. Sometimes it has 24 ports. Sometimes we can have 48 ports, right? So like this, there are a number of ports, specific ports. Say how many devices we can connect. If you have 16 ports, we can connect only 16 devices. So when you purchase switches, always you have to determine how many devices are there in your network. So according to that requirement, you need to purchase switches because these devices are very expensive. Okay, so when you plan for the network implementation, always you have to choose devices correctly. The switching speed. Now, when you learn TCP/IP, next year you will learn what is this switching, how do we send data packets, right? That data transmission. So you have to consider how much of switching speed is facilitated with switches. Network management capabilities. What is the operating system runs in this switch and is it configurable? Like this, you have to see what are the management capabilities. Embedded security technologies, any security facilities now with related to switches, common facilities, port security, right? You can enable certain devices into particular ports. So then no one can switch a new device into that particular port. No one can plug a new computer to over the to that connection. So like this, we can have some controlling in connecting devices. So security implementation is also should be checked whether it is capable to implement in here. And advanced switching technology. So when you want to expand it further, when you are connecting several networks together, and sometimes you have to connect several switches to each other, right? Switch is connecting to another switch in order to communicate with some other devices in different department. Like this, you have to think about, is it capable to do advanced configuration as well, right? So when you purchase devices, you have to always match them according to your company requirements or user requirements, right? And what else we need to think? As I told you, you need to build a flow plan. It's like an architecture, right? You have to design the flow plan and see what are the partitions, how many partitions are there in this particular flow, and how many devices are there in each and every section like this, how many users, how many devices they require, and what are the places they want to place these computers. That's also should be checked because when you place wall outlets, you have to have a proper notices related to places where we need to put wall outlets like this. We need to have a proper flow plan. Distance between the locations. Now it actually matters how much of distance we have from the server room to the other working area. Let's say you have 5 departments as we have considered in the flow plan in previous diagram, right? Here we have 5 departments. Now, how much of distance we have from the server room to the other departments? If you consider programmers department, sales department, they're actually far away from the server room. So you have to determine what is the distance between these departments to the server room, right? It's because based on that, sometimes we may need to go for a small telecommunication, right? So you have to determine what is the distance. Requirements of the network. Then basically when you consider other than the devices and all of the other factors that we have listed down in here, other requirements. What are the other requirements? How many employees are there? How many of them requires PCs? And technology. Also, we need to determine how much of strength like CPU capacities, memory capacities they are using in these devices. And also we have to know who are the audience, right? Who are the users? Because most of the time you can experience non-technical people in companies, right? In all of these organizations, unless it's a software developing company or IT related company, all of the other companies and organizations are having 90% of non-technical people, including the management, right? So they have less knowledge in technical background. So you have to be very careful when you deal with them and implement these type of networks, because always you have to consider who is the audience, who is the end user. Length of the cables. So when you consider the distance from the server room to the other department rooms, you have to consider the distance. Why is that? Because length of the cable matters. We can't exceed 100 meters in a twisted pair cable. So like us, we have some specified rules, like not actually rules, some specifications related to cabling given by TIA organization. So we have to consider them as well. What are the types of transmission media recommended for your organization? That's also you have to determine, because you can choose even fiber optic cables if they're allowing you to have it in your budget, right? So it depends according to the budget allocated by the organization. So sometimes you can implement your network with fiber optic cables, but in case you have to go for cheap solutions, then you can choose UTP cables. Physical security of the server and the network layout. Now, when you implement these floor plans, as you can see in this picture, server room and the technical support department is at the corner of the building. And this is where the entrance facility comes. I mean, entrance means entrance for all of the other employees as well as the customers, right? So as you can see in here, the server room and the technical support area is at the end of the building, and it's somewhere in the corner of the building, right? So from the intruders, you can protect your server room. Okay. And whatever the departments which is very closely contacting the customers are close to the entrance, right? As you can see, sales department is close to the entrance because they are usually communicating with customers. So then customer don't want to go into this location. So when you place these server rooms and technical telecommunication rooms, always you have to check what are the locations, physical location, right? And physical security of the devices. Okay, so those are the procedures that we need to consider. And then we have answer for question number 4. This is the answer, as I told you. We have 7 facilities, 7 subsystems. Entrance facility. So entrance facility means from where we get the connection. You can see from where we get the connection, right? This is the connection comes from the telecommunication service provider. Okay, entrance facility. And this entrance facility end up with a demarcation point. As you can see, this is actually connected to a rack in here. We can't see the entrance demarcation point. It's a small device actually. So entrance facility end up with demarcation point. So this entrance facility and the demarcation point is maintained by the telecommunications service provider. And from there onwards, we have an equipment room. Here we have the equipment room. So this is just a graphical picture. This is a equipment room. And this particular organization, we have several floors. So in each and every floor, you can see there's a working area. Here also we have working area with several users. And here also there's a working area with several users. So each and every connection is connected to a telecommunication closet at each and every floor. As you can see in this diagram, there are some closets in here, right? From this floor, you can see a closet over here and here and here. So these are telecommunication closets allocated for each and every floor. So the whole connections comes from the working area, comes over here and connecting to this telecommunication closet. Okay. And also you can see horizontal cabling, right? And vertical cabling, where we consider as backbone cabling, and the other cabling type is horizontal cabling. So cabling subsystem 1, we call horizontal cabling as cabling subsystem 1, right? And we have vertical cabling, that's the backbone cabling. Okay. So then I have some measures to share with you with related to each and every facility. Now, you can get more information about the entrance facility and equipment room, telecommunication room, all of these things from the reference, right? So I have attached a reference number 1. You can read it and find what are the meanings of each and every section. So this is the entrance facility where it shows the telephone communication service provider, telecommunication service provider, providing you the connection from the phone company line to your entrance facility. So this is the demarcation point, right? So this is your building. So from the demarcation point, it will send the connection to the internal facility. So entrance facilities contain the cables, network demarcation point, connecting hardware, protection devices, and other equipment that connect to the service provider or private network cabling. It includes connection between outside plant and inside building cabling. So this is the place where we can connect outside connection to the entrance connection. So as you can see, there's an antenna over here where they are getting a connection from wireless communication as well. So there also we need to have a equipment to get the connection. Okay, so this is the demarcation point. So I will quickly go through these things since you can read the description from the reading reference. And next we have equipment room. That is the most complicated place. This is what we call as the server room, right? So usually we call this place as server room. Okay, so in this equipment room, the environmentally controlled centralized space for telecommunication equipment is usually more complex than telecommunication room or telecommunication enclosure, right? Now, in this picture, you can see it's a very complex infrastructure we have, but usually in our environment also, you can see several racks where we have layer 3 switches and servers mounted in these racks, right? But in this environment, it's a very complex diagram where you have so many connections and different types of devices connected with each other. So this place is usually identified as the server facility or server room, and it's the equipment room actually. Okay, so in this picture, you can see it's a very nicely arranged one with the closed environment. So all the cabinets are enclosed with the proper closets. All these devices, right? Okay. So then we have backbone cabling and horizontal cabling. Now in this picture, you can find both backbone and horizontal cablings, right? So in cabling, with related to cabling, we have several subsystems. Cabling subsystem one is the horizontal cabling, right? In a building, the cabling infrastructure, horizontal cabling comes as subsystem one. And then we have cabling subsystem two and cabling subsystem three, right? Providers interconnection between telecommunications rooms, equipment rooms, access providers, spaces, and entrance facilities. So in a building, usually we have to lice cables from here and there to connect all of these devices to the server facility, server room, which we have recently identified as the equipment room. That's the correct name, right? But usually in naturally we use server room. That's where we keep the servers. That's why we used to call it as server room, but actual name is equipment room. So all of these connections are comes to this server room or equipment room as horizontal and backbone cabling. So cabling subsystem two, that is backbone cabling between the horizontal cross connect and the intermediate cross connect, right? So the connections from the horizontal cabling. Now in this picture, you can see that. Here we have the horizontal cabling connection comes to this closet. Okay. So that facility is the backbone cabling subsystem 2, right? Horizontal cabling connects into this closet via intermediate cross connects. Okay. And then we have cabling subsystem 3. In cabling subsystem 3, backbone cabling between the intermediate cross connect and the main cross connect, that's the distributor C, right? So that means in here, this connection is connecting other flows together, right? So that means the connection in between the intermediate cross connect and the main connection. Now this is the main connection. In blue color, you can see that's the main connection connecting all the flows together. So we can see it's the vertical cabling here, right? That's the main connection connecting all of them together, right? So horizontal cabling, horizontal cross connects comes into this facility and connect it in the intermediate cross connects. From there, intermediate cross connects are connected to main cross connect. So that's the subsystem 3. So this is the picture of horizontal cabling, right? Here you can see. And here also we can see horizontal cabling subsystem comes to a telecommunication equipment, right? Telecommunication room. So these are the cabling comes from the ceiling, right? So it's a ceiling, like either we can place these cables underneath the carpets, right? In usually when you implement these things, either you have to choose the ceiling or either we have to go for flow arrangement. Now, if you choose flow arrangement, you have to place it underneath the carpet. So you need to make arrangements with flow again, right? If it is a ceiling, it would be easy because if you take connections from the ceiling, anyway, most of these buildings are having ceiling facility. We can place all the cablings inside the ceiling. But sometimes we have to use cabling underneath the carpet because when it comes to work area, we may need to go for this type of cabling facility. Now in this picture, you can see on the on the second floor, they have horizontal cabling and they use ceiling to run this cabling infrastructure till the devices. But when you come to the first floor, you can see their connections are coming underneath the carpet to the devices, right? So it depends according to the environment, working area. You have to go for either horizontal cabling with ceiling facility or either the flow arrangement. Okay. So telecommunication room means where you have uh, connections comes to one single flow. Now, when it comes to several flows, we need to go for several telecommunication closets. Now, in this picture also, you can see there are three closets. Here it is the first closet comes from the second floor. There's another one to collect all the connections from the first floor. And here we have another telecommunication closet to connect with all the connections to this telecommunication equipment. So we may need to have several telecommunication closets to manage each and every connections in each and every floors. Okay. So in telecommunication room, the terminations of horizontal and backbone cabling to connect in hardware, including any jumpers or patch cords. So usually in this type of closets, we maintain all the racks and the closets devices. And here we have horizontal cabling explanation. So this is where you can see the horizontal cabling picture. Explanation is in here. The horizontal cabling system extends from the work area's telecommunication information outlet to the telecommunication uh, enclosure, right? Telecommunication enclosure. A telecommunication enclosure means telecommunication room, right? So all the connections comes from working area to the telecommunication room, right? So these connections comes to the telecommunication room. So this is where we have horizontal cabling. Working area means the place where all the users are working and where you can find all the computers, right? Work area components extend from the telecommunications outlet or connector end of the horizontal cabling system to the work area equipment. So here also you can see a telecommunication room or telecommunication enclosure, right? In this section, this is the telecommunication enclosure. This is the working area where you have several users, PCs, and other equipments, right? Even you can see at this point, they are using digital phones. So that means even the phone is connected to the network. And also we can see CCTV cameras in this environment. CCTV cameras are also connected to the network other than the PCs, right? And if they have printers, all of these other devices, hardware devices, if they are connected to the network, then all the connections comes towards the telecommunication group. So this is the work area and this is the telecommunication group. So then in question number 5, you can find standards and codes from the reference. Okay, so in the reference in page number 19, right? You can find what are the standards and codes used in structured cabling. So TIA EIA is the organization who provides you standards for cabling, right? So here you have the TIA EIA structured cabling standards. It's TIA EIA 568A, 568B, right? So commercial building telecommunication cabling standard like this. Cabling standards 568B, 569A, commercial building standard for telecommunications pathways and spaces. Like this, we have different standardization comes under TIA EIA structured cabling standards. And then we have some US codes. Right, some US codes in here. Okay, so these are the codes provided in US codes, and also iOS, International Organization for Standardization, that is ISO. They also provide you some specifications related to cabling, right? And this organization, European Committee for Electrotechnical Standardization, they're also providing you some specifications, guidelines for cabling standards, structured cabling standards. So then in question number 6 and 7, you have to find what are the structured cabling test methods, because when it comes to software technologies also, we have testing facilities, testing methods, right? So even in structured cabling infrastructure also, we have to do testing, right? So testing is a major requirement once you complete the implementation, and while you're completing while you're implementing the network, you have to do testing, right? So it's a major requirement before you provide the facility to the users. So these are the testing methods available in networking. We have wire map testing, near end crosstalk testing, attenuation to crosstalk ratio near end. So like as we do some calculations in here, but we are not doing any, like in detail, we are not doing these testing methods. Some of these testing methods check the voltage levels and the noise level, right? And calculate the strength of the signal or quality of the signal like this. We do some calculations. And these are the ways of taking testing methods. And then we have some explanations related to few of them. Wire map checks correct termination of cable wires in telecommunication outlets and patch panels. At the same time, it is able to detect any open circuit or short circuit faults. So when you connect cables into like let's say you are using UTP cables. Now, once you connect UTP cables with RJ45 connections, you have to see whether there are any short circuit problems. Is it connected properly? This connection and the RJ45 connector, is it connect properly? And also the wire mapping, patch code should be correct, right? We have testing tools to evaluate whether the cables are transmitted and connect them properly. But at the same time, you have to evaluate, like you have to check whether the patch code is correct. Now, once you uh, connect them into the RJ45 connector, you can't change it, right? If you incorrectly connect all the cables, colors into the RJ45 connector, we can't do any other corrections, right? So we have to reinstall, take a new RJ45 connector and reinstall it. Okay, so we have to check these things before you install the cable patch code. Is it correct, and what should be the other end? Like this, you have to evaluate it. Near end crosstalk or next, this occurs due to the alternating current flow produces an electromagnetic field around the cable. This field can induce a current flow in adjacent cable. So we are evaluating the crosstalk. We are evaluating the electromagnetic field in between two cable pairs in the same end, right? So attenuation is another problem in cabling. So that also will be verified by attenuation testing methods. And then we have attenuation to crosstalk ratio. So this is actually based on calculations by reading the attenuation level, and then we do some calculations and identify what are the faults. And in far end crosstalk or FEXT method, we are going to evaluate the electromagnetic field in two different points of the same cable, right? So we are evaluating the crosstalk in two endpoints. So one here, the other endpoint is the next end or the different end of the same cable. So you can find more answers from this reference as well. And also you can read the other references. There are two more references. So with related to testing, you have two other references like structured cabling testing and structured cable certification test. So you can read these two testing documentations to find more information about structured cabling test. Okay,